Okay. Well, let's see. For people joining this live stream, this is a meeting whose title I didn't quite understand. So I hope I'm about to be. It's called Bpe Encoding, Encoder, and Decoder. So I hope I'm about to be enlightened about what this is actually about. And by the way, let's see. Is Sushma here? Could you put tokenizers in our spelling list and tokenizations in our spelling list?
Yeah.
We'll skip that ridiculous German word. Okay, go ahead. What is this?
Okay, cool. So this is actually a very, very nice new feature for 12. And it basically is about tokenization. So currently we've got two different ways of tokenizing sentences. So there's characters and there's tokens. The negative of characters is that you basically have no, like English, you have a lot of information from like what words exist already in English. So character level models in general for neural networks, they're trained much slower. You need a lot more data to train them because they have to learn things like spelling. On the other hand, tokens, which is like finding words. So this tokenizer, for example, it'll find spaces in the sentences, and it'll try and create some list of tokens.
Okay.
It has to have all kinds of special logic for dealing with punctuation and whatnot. So the problem with this is that for English, you can maybe make this work with normal tokens, but as soon as you enter things like machine translation, all kinds of crazy things happen in other languages. So, for example, German, it
smooshes words together.
It smooshes words together, and yeah. So basically, there's a solution now that has become the standard method for things like machine translation and all kinds of other NLP tasks.
Okay.
And it's basically a trained tokenizer.
So hold on a second. In our tokens, the thing you showed with that net encoder with tokens, I don't know what that mapping is. And I mean, we have burnt in some mapping, some default mapping for the net encoder with tokens. Is that correct?
Correct. So it's basically, it's the English dictionary. It's word list or something for English. I think it's equivalent to this.
There are a couple things in a word list that we remove.
Like what?
Honestly, I can check.
For what reason and why? I mean, so an example of something that's happening to word lists, the default, if you're using that one, there are many different kinds of word lists. So, for example, the default in version 12 excludes words that basically aren't G-rated words. Okay, so we had removed previously by default. So word list has an option. I forget what we're now calling it. It used to be called, gosh, I don't remember. We went through so many different iterations of this thing. But I think it for example, there are words which are definitively bad. There are words that can be interpreted badly. There are words that will involve tittering among the middle school kids, that kind of thing. And we have a variety of choices of those. And I think there's some default setting that won't include all kinds of profanities and things. So I don't know what you're exactly using here, but whatever that mapping, whatever that thing is, don't assume that the numbers that you get out will be in any way stable.
No, we don't assume that.
Okay.
So the thing is, once you've created that net encoder, it stores the full word list in it. So it is after that it is stable.
Yeah, exactly.
Yeah, the things that are right now, and someone on the live stream is commenting, it's common words and known words. Yeah, that's what they're called right now. We have a new option which has many settings that determine whether all kinds of words that some of which are probably unsuitable for live streaming or anything. Okay. So anyway, so this is a new approach that is not based on words. I don't know why we call it tokens rather than calling it words. I mean, characters and words seems to me to make more sense, given that thing is coming from a word list and the other one is coming from an alphabet. Right?
So tokens can be more general than words. So they could be...
Okay. But what are we doing? And can I see the documentation for net encoder tokens?
Sure, okay. So for example, like New York might be a token, but that's like 2 words.
Sure.
So net encoder tokens.
Okay.
Oh yeah, sorry, language. So this will be...
Yeah, all right, fine.
And there's all kinds of case, things about like ignoring case and split patterns, etc., etc.
Yep. Okay, I get it.
Okay. So it's a messy business, and it doesn't scale very easily to other languages.
Encoding is always a messy business, but go ahead. Okay.
So basically, there's this new approach.
All right, fine. I believe you. So tell me about the Bpe encoder.
Yes. Okay. Cool. So basically, Bpe encoder, it just has, so as the paper says, they're called subword units. So it can learn pieces of words.
Okay, I get it.
And so it's like an interpolation between character level and word level.
Yep.
And it's trained. There's some libraries that you're training.
I mean, I hope it's not primarily, these agglutinative languages and so on, of which I think Hungarian and Finnish have even more bizarre kinds of setups. I mean, that's okay. I hope it's not sort of just optimized for those, but go ahead.
Absolutely not. So the main way that people use this is probably going to be via NetModel.
Yes.
So we have, for example, there's one site that has...
Okay, fine. What is your proposal?
Okay, yeah, cool. So, but this context is important for the design. So basically, there's two different philosophies we can take for this design. So the first one is that we allow people to specify this encoder like normal encoders, like you give all the information that's required to construct it. So like you give a token list, it has a whole bunch of parameters. On the other hand, no one will actually ever use this form.
No, they'll never do it. It's way too complicated.
Okay. So basically, we think for 12, there's a very simple solution. So obviously, NetModel will give people, those 275 pre-trained models. But we'll also support a file syntax one. So basically, Bpe Encoder file that will take a Google sentence piece pre-trained model, and it'll construct the net encoder.
Why are we doing that? Why don't we just put those into NetModel? You mean that these are arbitrary ones that somebody else has produced?
Yeah, because that's a toolkit that you can use to train your own. Except
that we can't do training of this Bpe encoder. We won't be able to do training directly, right?
Not immediately, but I don't see any reason why we can't have.
What kind of training does this involve? I mean, this is a feature detector of some kind that needs to be trained. Yes.
Yeah.
Correct.
Yeah.
So basically,
it's not the only example. Go on.
Yeah. So it'll basically be like training string one, blah blah. There'll be some corpus of either strings, or there might be a text file or something that you trained on.
I don't particularly. Yeah, I don't want to commit us to that syntax because I think there might need to be other options.
I think there'll need to be a lot more detail about what the training corpus is. Just having a great big blob of, here's a gigabyte of text. Be happy. Doesn't seem.
Yeah. So one possibility is net encoder train or encoder train or train encoder, something like that, because then it's not the only encoder that you might want to train. But that's a whole nother can that we don't design.
Okay, so hold on a second. I mean, the fact is, for the typical languages, whatever it is, these 275 languages or whatever it is, what's wrong with those encoders? I mean, so there'll be some standard encoders that come from the NetModel. What's wrong with those? Why would somebody want to do something different other than for research purposes?
So they might have, something else. Like they're training on SQL language or something.
Okay.
Programming languages, or they might train on.
Don't we also have
chemicals?
Okay, fine, but I don't understand. I mean, they can write their own encoder. Period. From scratch. What's special? What is the characteristic of a Bpe encoder? What does Bpe even stand for?
It stands for byte pair encoding.
Okay, so what does that mean? So basically that means the destination is there's something goes in and byte pairs come out. Is that correct?
No.
It works in exactly the same way as other tokenizers. So you give it a string and it returns you a list of integers.
Right, but why is it called byte pair?
It's a detail of how it's implemented. It's not even a very good description of how it's implemented. But
I mean, a byte pair would get you 65,000 possibilities. Is that what it does?
No, that's why it's a bad name.
Okay, well, what is it? What is it? Tell me what it is. A, what is it? B, what does byte pair? Why is it called byte pair?
So byte pair, it comes from the. Oh, sorry, Matteo, continue.
Yeah, it's inheriting.
Matteo, you need to speak up or we can't hear you.
Oh, sorry. I'll increase the volume. Sorry.
We can't hear you unless.
Is this better?
Now you're very loud.
Oh,
And you're
okay,
echoing.
what about now?
That's better. Okay, go ahead.
So,
what were you going to say?
So it's basically, it inherits the name from a compression algorithm, which which had nothing to do with like language and tokenization of strings, but just with byte sequences. And it's a compression algorithm which basically you count all the possible adjacent pair of bytes and you create a new symbol for the very frequent pair of bytes. It's just that.
Okay. But okay.
So and it turns out that it finds good pieces just naturally when you do that. The compression.
Well, it's like an n-gram thing. So it's finding common n-grams. Is that the idea?
Yes.
Common diagrams.
Exactly.
Okay. I mean, and you think it should be called Bpe Encoder, even though it's a bad name?
Well, we're not. This can be debated.
That name.
So it could be. I mean, yeah, like byte pair.
That doesn't seem to help anything.
No, yeah, I think we picked Bpe because it's the least bad of all the different options.
Exactly.
Fine. Okay. All right. Okay. Okay. So now explain to me. Okay. So most of the time, people are going to use the encoders. They don't care whether they're a Bpe encoder or anything else. They'll be an encoder for a given language, right? If this is the best encoder to use for English, why not just have them? Why not just have a net encoder, language or something?
Maybe, but I mean, even there, like the kinds of characters you see in Twitter are still very different from what you'd get from like a more traditional.
Okay, I understand, but okay. So how does somebody make a Bpe encoder right now?
So yeah, so let me just lay out what I think we should do. Phase one is just get things from the model gallery, right? Yes. And that's the only thing people can do. Phase two is they can use their own, by hook or by crook, they get their hands on a sentence piece encoder, and it's just a file that just describes the encoder.
What format is that file in?
It's a protobuf file.
It's a protobuf file.
Great, but what format is the protobuf in, so to speak? What's inside there?
So it's a bunch of metadata. So things like the chunks, the token chunks.
But just saying it's protobuf doesn't tell one anything, right? I mean, it's like saying it's JSON, and it, but then what? How do we decode that file?
Yeah, protobuf is different from JSON in that it actually has a schema. So there is a schema for sentence piece encoders. And my point is, with this file syntax, it's like we supported an import, but it's just something we can actually deliver for this version, and it's quite lightweight. There's nothing more to say than the sentence piece is a weird file format. You import it, you get a Bpe token encoder. We don't need to make an import page for this one weird one-source format. We can just support it in the construction spec.
By the way, somebody is noticing that you have an eclipse icon in your, that's not my screen, that's Sebastian's screen that we're watching now. Just in case you're wondering. We have a nice Wolfram workbench, but well spotted. Good screen tourism.
So you see what we're saying? We're saying you can make your own, you can train your own thing using off-the-shelf software. It's not part of Mathematica. And once you've done that and you want to load that encoder in, you can do that using this file spec.
Okay, but why don't we give it a name? I mean, is there a format name?
I think it's pointless. It's pointless to do that because it creates a lot of work for us. And the only thing you'll ever do with this is it'll become a net encoder. You can't export.
No, I get it, but this is not just some random file from the wild web, so to speak. This is a file in some very specific format created by some very specific, system that's training Bpe encoders. Yes.
Correct.
Yes. Correct.
Okay. So what is that thing that is creating that file?
Sentence piece.
Which is a thing called sentence piece.
Yeah.
Okay, it's a library called sentence piece. So it will be described as a sentence piece file. Is that correct?
Yes.
I guess so, yeah.
Okay, so it's as if we had a thing which was in our an import format called sentence piece. Mm-hmm. And that or sentence piece encoder or something format. We could call it sentence piece encoder, and that what that does is you read that in, and it becomes a net encoder. In other words, that's an import format, and what it returns is net encoder of blah blah blah.
Yes, we don't propose to do it that way for a couple of reasons, but yes, theoretically, yes.
Why don't you want to do it that way?
Because for now, there's no other way you could create one of these net encoders in the first place. So if you're thinking about what the actual usage line of this net encoder is, the only way you could create one is from one of these files.
All right, fine. Well, fine. So you say a sentence piece file in protobuf format or whatever, and you just define it that way. I mean, it's kind of
it's like a Deus Ex.
What?
So Deus Ex, it just comes out of just God made these, and you know.
Oh, Deus Ex Machina.
Right.
Okay.
Sorry, my Latin pronunciation is not Eton level.
No, they've changed all the Latin pronunciation since I learned it. How that could happen after 2,000 years is unclear, but let's not worry about that. Okay.
Yeah, so this allows us to basically document this thing as a
That's
format.
fine. I don't see a problem with that. But what's more important is that for English, for example, the default, what's going to be the name? How is this going to pick up the default English encoder?
Okay, so I think there's a fairly so there's a few things we can do here. So I think the zero argument form should do something similar to what tokens currently does. And tokens does have this form where
we have common language.
Like English or something.
Fine.
So that could be net model basically. What's wrong with that?
It calls net model, yeah.
Yeah, that's fine. I'm good with that. I mean, we have to have a standardly named. What will be the name of the net model that this accesses? Because what we want is that a standardized name, so that if, for example, that second thing is SQL or something like this, then we could imagine having a standardly trained net model. I mean, if you think that this is the wonderful encoding for natural language, then I think having Bpe tokens in there is rather obscure. I mean, why not call it something which is a bit more, actually, but suggested Carl Lang on our live stream suggests subword tokens as a more generic name.
It's not bad.
Yeah, that's not bad.
I'm not sure whether the word should be capitalized. I think it would be subword with a lowercase w. I personally think that's a lot better than Bpe tokens, which is kind of meaningless.
The spot that puts us in design-wise is that if there's more than one method, subword token is a sort of general concept, right? And if there's more than one method, then all the sort of parameters that this encoder has inside it and the implementation it has, we have to sort of multiplex multiple of those into one net encoder spec.
Well, we could call it Bpe subword tokens. That way people have a fighting chance of knowing what the thing is.
Yeah, I do prefer Bpe subword tokens over Bpe tokens.
Yeah, it's much clearer what they do.
Yeah. Okay, I like that.
Good, thank you.
Thanks, Carl.
Unfortunately, there's no credit for that.
Okay.
This is a live record that will be there for eternity on Twitch.
Right. Oh, that's true.
For better or worse. Okay.
So
keep going down. Parameters that we need. So these are all.
Matteo will show these parameters. So he's going to share the screen. So just explain what some of these parameters are.
Sure.
And some of them are actually quite interesting for Wolfram language in general.
Okay. Share, Matteo. We're waiting. Share your screen.
Okay, so the most
make it slightly larger
is this Unicode normalization. So
Matteo, could you go to 125% magnification?
Sure. Is that better?
Yep, that's fine.
So Unicode normalization is a preprocessing step in which you basically resolve some redundancy in Unicode representation, in this case in UTF-8 representation. So for example, like these two characters, So, okay, on this front end, they don't have set exactly the same, but in general, they can. And they are semantically the same. And one is...
I understand. So we've, do you know, I mean, within our character data setup, we've got all kinds of transformations. And maybe not this one, but this one might be an interesting one to have.
Okay.
This is definitely an interesting one to have.
Yeah, exactly.
So let's see. Who could somebody maybe get I don't think we have the right people to talk about this in general, because we've got I mean, this also relates to transliterate and those kinds of things. Oh, this is interesting. Yeah, okay.
Okay, so there are various schemes of UTF-8 normalization, and they're basically defined by byte replacement tables.
Yeah, I get it. Right.
So the backend.
Okay, so hold on a second. Can somebody ask, somebody contact Alan and just ask him to either join this for a minute or to tell us who deals with character data and get them to join us.
Okay.
I think Francisco might be the person doing that. I can't remember.
Okay.
Okay, so there are various schemes, and like we currently support a particular one, which is this NFKC, plus a custom modified version, which the people from Sentence Piece implemented. Which I mean, we have a question for this because it's unclear how to name it.
Yeah, I understand. Okay, so first point is there's this sort of folding of Unicode space to things which are to the minimal code point that visually looks like something. Is that the basic idea?
That's some of these schemes have these purpose.
Okay, fine. So that or it could be U umlaut turns into U double dot or whatever. Is that the idea?
Yes.
That's what you said up there. Okay.
In general, it's about to resolve redundancies.
No, I understand, but that's not unrelated to transliteration, which is well supported by this library. What is it called? CT. Gosh, I forget what it's called. There's a library that goes along with Unicode that supports romanization and that we have been progressively adding to. Okay, so ignore case. That seems perfectly reasonable. Is there an issue?
So, well, no, there is no particular issue for this. Like the only additional piece of information is that basically this library supports generic UTF-8 case folding, which covers like all the weird UTF-8 characters.
Yeah, I know. Well, so does to uppercase from uppercase. I mean, this has been extensively worked on over the years.
Okay, fine.
All right.
So that's a pretty clear design, yeah.
Yeah. So then we have so the additional white space basically can insert. It's another preprocessing step which inserts a white space either to the left or the right of the input string, and this is done in order to segment the input string correctly according to how Bpe works. So I can go a little bit.
So there's an unbelievably detailed thing about this particular scheme.
What do you mean?
These extra options here are pretty obscure.
Yeah, they are.
But they're needed because certain models.
Okay, so what is your objective in this meeting? You want names for these options?
I think
we
so.
already
Yes.
have names for these options.
Okay, so
decide on names. Yeah.
Yeah.
Right.
Well, the only part we are unsure.
Okay, they're string options, right?
Yes, they're string options.
Yeah. The only thing we're unsure what to do is how to call this modified NFKC scheme. And again, we need it because it's the default in Sentence Piece. And
well, why don't you just call it modified NFKC? If that's what you're calling it, just call it modified NFKC. I mean, all of these things at this point are kind of, telling jokes by numbers. But you have to understand what all this stuff means, or you just have to copy it from some example, or you're not going anywhere with it. This is hardly a first principles situation.
Sure. Well, but do we also we probably care about also explaining how this modified NFKC is modified from the original NFKC?
I don't think so. People will just try it and see if it works.
Okay.
I would just call it modified NFKC and say that's the default.
Okay.
I mean, this stuff is still in fairly rapid motion. It's not going to, I would hope that within a year at the most, we will be able to have sort of the definitive language encoder, and that's just the thing people should use.
Yeah,
but we don't have that yet, because, and in fact, that's what you were proposing at the top there, modified NFKC. So I just looped back to what you already had figured out.
Okay.
Okay, so this additional white space thing.
Yeah. So
added white space or something.
Added white space.
I think added white space or inserted white space.
Well, what about padding? We do have the notion.
That's a good idea. White space padding.
That's a good point. And the left and right, perfect.
Padding. Okay. Sounds good.
And
so
in the meeting we had, we didn't call it pre-merge. We just call it merge white space.
Okay. Sorry.
Yeah.
Well, what does it do?
Yeah, that's another fairly technical option. So basically, in this algorithm, the way you start is that you segment an input string into the characters, and then you start merging adjacent symbols according to some rules.
Okay.
When you enable this pre-merge white space, the first thing you do without even looking at your model definition is to merge the white space either on the right or on the left of the word, and then go on with what your model defines.
Okay, I get it.
Actually, merge white space is not a good name.
No.
What about collapse white space? That was one of the options that we discussed earlier today.
That's yet another one, actually.
Okay, but we've got to actually look at all of them.
What is there another one?
This list is incomplete, apparently.
It's combined white space. Sorry, I forgot about that.
By the way, all these things are symbol names, right? I mean, string names, right? There are no symbols.
String names, yes.
Yeah, these are all strings.
So basically, this guy, true or false, it basically collapses adjacent white space to one. So
okay.
We didn't call it combine. I think didn't we call it collapse?
No, pretty sure it was combined.
I think combine is right for what you're talking about here.
Yeah.
Okay.
So this guy is mapped into. You get it.
I understand.
Yeah.
I understand. Okay, so this merge thing, gosh, I don't know. This is unbelievably technical. I mean, just call it pre-merge white space. What's that?
Yeah, I think it doesn't matter too much for this. Because again, users aren't setting these options. They're
okay, so call it pre-merge white space. And we'll be good. Okay, what else is there to figure out here?
There are no other options.
I think that's pretty much it.
Okay. Okay. So this Unicode normalization thing seems like that would be an interesting option for things related to transliterate, and you should communicate that to Alan and Francisco. So Sushma, maybe you can do that.
Mm-hmm. Yep.
And I mean, what we probably should do here, if you give me back the screen.
Sure.
And that way we'll find out only the applications that I have, as opposed to people are asking here on the live stream about whether people prefer using Wolfram Desktop, Mathematica, Wolfram Workbench for. The answer is that a lot of people who write really large blobs of code and interact a lot with our Git system and so on do often use Wolfram Workbench. And there's a pretty nice integration, which hopefully will make available one of these days to the public, integration with Git that's been built there. But people like me who write smaller lumps of Wolfram language code tend to use notebooks and package files. And I think fairly common is to use some No, why is this not doing that? Hold on 1 second. I just want to look at these character encoding things for a second. And hopefully I will be able to use, let's see, there's the version 12 head branch build. Yeah, fairly common is to use package files and the package editor. But failing that, and that's sort of the junior version of workbenchy type stuff. Okay, let me just take a look at the all the stuff to do with character names. Yeah, the various people are pointing out that the string names in these net encoders are annoying to not be symbols, but they don't really raise to the level of being symbols that have global usage. They're really things that are part of a very local function. Not the best thing, but this is still an area in rapid development. Okay, let me just look at this stuff to do with character functionality. Let me just go to one of these. Let's hope this is working now today. Okay. Okay, what I'm looking for is, I wonder why this doesn't have, it's actually not good. This really should have transliteration and things on it. Transliterate. That's, okay, so that's a transliteration operation that will take this and turn it into that, right? But what you're saying is that effectively this thing is like a transliteration, but it will reduce things to canonicalized Unicode code points. Is that correct? By the way, could you, I don't know why that's red, but can you report that?
Yes.
So it's possible that we could put this thing into transliterate. I think, I'm trying to think about, okay, remove diacritics is another related thing. Makes sense? Yeah. I mean, perhaps there should even be a function for canonicalizing characters, because I agree that this is useful. Or is it basically transliteration?
I don't think it is. I think it's very specific to Unicode, because it's kind of like Unicode spec defines what makes two Unicode code points the same thing.
No, it doesn't. They're not the same thing. They're never the same thing. I mean, a typical example of that would be, capital alpha, right? There it is.
Yeah.
Okay. Right? And it looks like that. And now let me put in a capital A. Okay, it looks like that in that font.
Yeah.
Right? So the question is, I assume that your normalization would take that capital alpha and just turn it into a capital A.
Is capital alpha one of our things, or is that in Unicode?
Of course, it's a Unicode code point. I mean, if I say 2-character code of this, it'll be about 900 and something, I think. 930.
No, but
capital alpha.
There's a reserved space that we put all kinds of things, including
that's different. That's private Unicode space. That's quite different. That's up close to 65K, 64K, right? This is all standard Unicode. Our mapping of things like the name capital alpha is special to us, but the fact that it is a Unicode code point at 913 is just, it is what it is.
Right. Okay.
So what I'm saying is, this is what you're talking about. I assume in that normalization is you could take code point 913 and see what it maps to. Maybe you can tell us, Matteo, what it maps to.
No, I don't know the details of the replacement.
No, but just run it. Just run it.
Oh, sure.
Just take your net encoder and type in a capital alpha and tell us what it gives you.
Definitely.
and I predict it's going to give you 65.
Well, it's not that simple because that's a pre-processing step, and then it has to run through the matching of the tokens.
Yeah.
Okay, so that might not work. But so the main takeaway from this.
Run it on capital A and on, just run it on the two separate strings and see if it's the same
see if
token.
they come out the same. Right, that's an easy way to do it.
But I'm almost certain it's not. This shouldn't do this. So alpha is a very different. So it shouldn't convert alpha into A.
Why? That's exactly what it was trying to do here. If it's going to convert, so, that's the whole point. It's folding things so that
my understanding of this as well is that there's different ways of representing the same grapheme from Unicode's point of view. Like, for example, you can start with an A and add a diacritic on it using a combining Unicode character that combines with the previous one. And they consider that to be a degenerate representation of the same grapheme. And Unicode has an opinion about what those rules are. And this is what it's meant to do, is canonicalize them to one version of each of those equivalence classes. It's not about transliteration. That's the wrong way to think about it.
Okay, listen, we've got people who are experts on this whole Unicode standard, and they're not people who are in this meeting. I mean, as an amateur, so to speak, there are these things. You are completely correct. There are languages where they come from dead keys on keyboards, and they're characters that are like that work like that. I think in more exotic cases, there are. I think Khmer has one of the most exotic things, which has languages with hats and feet and all sorts of diacritics all over the place. And I'm not the expert on this. I understand. This seems like, look, basically what we're doing right now is we're simply trying to get an encoder which does a sensible thing for typical pieces of language. And I think it's an interesting point that there should be something that canonicalizes those things. That will be a good point for Alan and Francisco when they're working on character data, but I think it's not relevant to this. Okay, anything else we need to go over, guys? I hope this is, we're getting to the 11th hour, obviously. Hopefully you guys are getting everything together for the final builds, yes?
Yes, there was one thing that I wanted to run by you, but yes. I wrote it down, but where did it go?
The question is, does the Unicode function work with emoji? The answer is, for version 12, although we're not making a big noise about it, emoji will work in the kernel. Emoji are not plain zero Unicode. They're Unicode characters above 65,000. And we are now supporting in the kernel multi-byte, more than 2-byte Unicode characters, but we don't yet have display on all platforms of those things. So, for example, the emoji you just put in, I would strongly suspect, I don't even know how to get it out of this. So, oh well, so much for that. It seems to be a bitmap. The answer is that at the kernel level, we will be supporting emojis starting in 12.0, and soon thereafter, they will start to be able to be displayed properly in the front end and so on all platforms. That's been a very complicated thing to support efficiently. Sorry, Tally, what were you going to ask? Tally?
Yeah, I can't find my note. I'll just have to ask you another time.
Okay, sounds good. Okay, well, for people on the live stream, we are about to start a general language design live stream and preview. What's our agenda? Okay, all kinds of things coming. All right. So we'll be back on the other live stream, and neural network folk. Talk to you all soon.
Thanks. Okay.
Bye.
Okay. Bye-bye.
Bye.
Bye.